Hello, welcome back again to the Geography 300 Geographical Data Analysis video series. We saw the motivations for sampling in the previous video. Now we're looking at different types of sampling, especially within the context of making sure it is a good representation of the population of interest. And before getting to the exact types, that's an important point to make, that you need to know what your population of interest is before you go in. If you don't have that clearly set out, you might get the wrong sample. So that would need to be understood both in terms of the non-spatial or attributes of what you want to observe, whether that's people, whether that's elk, whether that's soil samples, to take the ideas from the previous video. Like, what age distribution do you want to have? Another thing would be making sure you have the study area identified. In the COVID example that I had from the previous video, we made sure to limit to our study area to Appalachia. There were reasons for that, especially recognizing both social and cultural issues might make Appalachia different from the rest of the country, but also COVID entered Appalachia later than many other areas of the country. West Virginia was the last state to see an infection, to see a case of COVID, for example. How did that delay play out in people's attitudes? So we set up that particular study area before we decided anything else about the sample. Then once we have those parameters, those ideas in mind, we then can go and decide what of the different types of sampling we would want to use. So now moving on to that, the first type of sampling is true random sampling. In a true random sampling, any person is equally likely to be in the sample than any other person. That would be if you had a set of phone numbers, a phone directory, like the phone directory for, say, WVU, or the set of geography majors for WVU, and we wanted, say, a sample for an in-depth study of how you think we're doing, for example, to say, okay, I'm going to take 1/4 of the majors and have them fill out this very lengthy survey. The 1/4 then, each person by that would be equally likely. And whether I pick one person has no bearing whatsoever on whether I pick anybody else. The second type is called stratified. Within a stratified sample, we have some categorical variable by which we are grouping each of the people in our study. To take the idea with the geography majors, we could say, I want to make sure I have an even representation of every class, freshman, sophomore, junior, senior. By the nature of how people come into the geography program, at least at WVU, most people start out in some other program, take a geography course, decide this is really interesting. I want to switch. I want to either add geography as a second major or switch away from my previous major. That means we have more juniors and more seniors than we do freshmen and sophomores, because the freshmen would be the people who just come in knowing geography ahead of time. That happens, but it's less common as an entry point to the major than transferring in. So I might then want to stratify. Instead of, I want a sample of 12 geography majors, and it's going to be random. I can pick any 12. We might instead say, okay, I want to make sure I pick 3 from each of the classes. That ensures that I have representation from each of the classes. The freshman class might be poorly represented in a truly random sample. That means, though, that the probability of inclusion, a freshman might have, if there's only 4, might have then a 75% chance of being in the sample, whereas a senior, if there's 20 seniors, the odds of them being in there is about 1 in 7, so, or 14% roughly. So the probability can vary, but within the group it's equal. So we pick randomly within the group, but we sort by the group first. That is a stratified sample. A systematic sample, at first glance, this might actually seem like it's very similar to the random sample. When I say taking every 4th person, or 10th, or 12th, or however many, instead of it being truly random, it's saying there's a system to this. I am, say, alphabetizing everybody. And I am taking the 4th person, the 8th person, the 12th person, and so on. There is a very clear system to that process. In this case, it's probably not going to make much of a difference. If, however, I sort by GPA, I might then have and say, okay, I want to take the top GPA person, but then I want to have a nice range throughout. It's kind of, so within this example, having sorted it by a continuous variable, you could almost think of it as kind of like a continuous version of the categorical stratified, but that doesn't always hold true. And here, okay, I've sorted by GPA, and I want the 1st person, the 5th person, the 9th person, the 13th person, and so on, to make sure that, again, the opinions that I collect through the survey represent the full range of GPAs within geography. You may notice that both the stratified and the systematic, I'm trying to make sure certain groups and there's a good representation. This gets to the idea of a representative sample. These may then be more representative than a truly random sample. That would be the motivation for doing this. And again, it gets to what is your target population. If you want to make sure your sample is representative of that target population, you may when to employ one of these strategies. The fourth type here is perhaps might seem a bit, why would you do this? But I'll get to that. So I put down here a random start. It doesn't have to be random. You could actually do a cluster sample starting off of the other kinds here. But you pick somebody. Within the matrix, it would be saying, okay, pick some. I pick John to start with. Then I build a cluster around that initial pick. So within that, it might be saying, okay, you come and you bring to the sample 4 of your friends. So now I have a cluster of 5, and I might take 3 clusters of 5. If I want to make sure, for example, I'm collecting people with interests in the different parts of geography, I might say, I want John representing human geography, and Jill representing physical geography, and Jane representing GI science. And I ask each of those 3 starting people to then bring 4 of their friends. Chances are their friends, by virtue of having been in more classes with them, might also be in those areas. So then we can make sure we have a cluster within each of the 3 parts of geography, and use therefore a cluster sample. The 5th kind is simply hybrid. Within a hybrid type of sampling, it's a mix. So we might say, okay, I'm going to start with a stratified sample and put everybody into groups. But instead of it being random, I take a systematic sample within each of those strata, within each of those groups. Or I might say, okay, within this group I want a random sample, within that group I want it stratified, or sorry, systematic. So we can have combinations of these. Again, the rationale for those decisions gets to what would best provide a representative sample. In what situations, or how can I construct the sample so that it best stands in for the population in our subsequent inferential tests. In this example, we have we've developed our sample characteristics based upon the attributes. We can also, in geography and spatial data analysis, build our sample upon spatial versions, basically spatial versions of these same categories. And we will see that coming up in the next video. As always, if you have questions, feel free to ask. And have a good one.